Recording in progress.
All right, let's give this 3-1 another try. This is defining the derivative. So we've been doing a lot of stuff with limits and working with secant lines a lot. And so the secant line is where a graph is crossed by a line at 2 points, or any surface or segment is crossed by a line at 2 points. So that's what I have showing up right here in like the orange. Let's see there. Yeah, that'll work. I got it right there. But at some point you want tangent line, and you'll only have at one point at the tangent line. It's only touching once, but to have a line, you need either a slope and a point or 2 points. And with it being the tangent line, where that option is out. So we need a slope and a point. So to get the slope, with the slope, you also need 2 points to get that. So what we do is we build off the secant. The slope of the secant line this is very much like doing, it's not going to show up in the dark screen background. Let's change to white. This is the m you remember from algebra, y2 minus y1 over x2 minus x1, where y is f of x and x1 is a. That's the only difference right here. And so we have a couple ways of doing that. We can do a is our first point, and a plus h is our second point, which is the setup we have here to find the secant line. Or we can do x going to a, using x and a, and that's the setup I have right here, the first one. So in both cases, to get the tangent line, we want to slowly move this point closer and closer, and the closer this gets, the better the secant line starts to look like it has the same slope as the tangent line, until the points are so close, they're touching and they're almost indistinguishable. Your tangent line looks like your secant line. And to do that, we're going to do the limit gosh darn it, there we go. We're going to do the limit as x approaches a, or in this case, a and a plus h makes this distance here h. And so the other option is doing, so we want x to go to a or h to go to 0. And in both cases, we're going to do a limit. Okay. So we get down here. So to get the tangent line, we can either do the limit as h goes to 0. And this literally, this f of a plus h minus f of a over h literally stems from plugging in x equals a plus h up here into f of x. And you can see, and we plug it in down here for that x, and then a plus h minus a equals h on bottom. That's how we get that down there. So this one literally comes from doing that, x equals a plus h. Both of these versions work. This is the version more commonly used for derivatives. So we're trying to find the slope of that tangent line, because then when we have the slope, we also have the point on the line too, and we can make the tangent line. And this is kind of useful. This is obviously filmed after I did something in class. When we know the slope is 0 for the tangent line, we can use it to find the top of a valley or the top of a peak of a curve. We can find the top up here. we can find the bottom down here because the tangent line, and so finding this derivative stuff works. And so when we do these, we call this f prime of a. I give an example right here. When we do f of x equals square root of x, we want to find the slope of the tangent line at x equals 4. So we go ahead and we plug it in, and I actually did both versions. So this is the f of x minus f of a over x minus a version right here. And when you plug it in, this is why we practice multiplying by conjugates. You clean it up, and when you finally get down to where you can plug x equals 4 in, that's where the limit goes away. You want to keep writing limit the whole time. I've seen students messing up doing that. Notice I've got limit written the whole way. And as soon as I plug in x equals 4, no limit written anymore. And I get the slope as 1/4. So that's the slope of the tangent line. You should be able to get the same thing doing the limit as h goes to 0 of f of a plus h minus f of a over h following this method. So when I plug in the 4 plus h, a is 4 here because it tells us that's the x value we're doing it at. Okay? You'll find it's the same. You still got to multiply by reciprocal, or not the reciprocal, the conjugate. You still got to clean stuff up, but when you clean it up, you still see you get 1/4. So we call this step here, when we're doing it, we say this is f prime of a. That's how it's pronounced. And it's really the prime, that's the prime part. So this is like f of a, but we have prime in there, so we say f prime of a. And we can find it either way. Okay? And f prime of a is the derivative of f of x evaluated at a. That's the basis of what we're doing. I'll stop this video and do some more. This is the idea of what we're doing.